Good evening, all. I hope you're all doing well. We'll start the session. Shashank sir, good evening.
Yeah, good evening, ma'am.
Yeah, you can start the session.
Sure, sure. All right. All right. So good evening, everyone. Welcome to the session. Right. So this is day 3 on our 15-day journey, right? On the student development program on Agentic AI and Applications. Let us start the session. Okay. So yesterday we stopped with an interesting topic, which is GAN, right? So a lot of people were asking a lot of doubts. So just before starting, if you have any particular doubt, you can just post it. You can just post it so that I'll take up a couple of minutes to answer your questions. Then we can go into the session. Then again, probably after half an hour to 40 minutes, I'll take your questions. Okay. So you can just post your questions and just waiting. Good evenings. Okay. Good evening is fine. So apart from that, anything in particular? What is okay? Uh, Orchestra system, that music. I think it's a promotion. So that it's Excel as promotion. And next thing is about the prompt engineering you were asking. So prompt engineering, just be uh, you know you can just wait because I'll cover the topic on prompt engineering as well. So you need not worry too much about that now. In particular, I'll cover that concept. Okay, I'll cover that concept. So anything else apart from that? So anyway, that I'll cover. So you need not worry too much about that. Okay. Uh, Apart from that, anything else? If you have, you can ask me. Right. I okay. You can just search it, Akshat. You can just search it, Akshat. You'll get it. You'll get it. Just search for XLR. You'll get it. Um, this is my first session. I want to know whether there is a certificate provided. You get any mail about this. About this, you can you can contact numbers. Uh, okay. So who are the hosts of this meeting? You can contact them. So they'll I'm expecting questions on the subject related, something like that. Then on okay. Yes, definitely that will be provided. That will be provided to your that already has been already shown. That already has been shown. You'll get the recordings actually. You can contact the admin team. You'll get the recordings. There you'll get it how to see your dashboard and all. Okay, that has been showed in the first session. That's why you have to attend from the starting actually. It's a process. No, every day we cannot show that because we have few things to deal with. Okay, so probably you can request the admin team. Okay. Okay. All right then. I think most of you are admin related questions like mail, website, nothing about nothing about the subject. Okay. Okay, fine. So no issues. That is also important. This is also important. Okay. So let us so just to revise you or keep you in the buffer for the memory. So what has happened, so we started to understand the a few concepts especially, right? And in yesterday's session, right, we have talked about especially the concept of how AI. I focus more on the journey of artificial intelligence, because it is a process, and that is what actually we need to understand as well. So that I've clearly explained to you, right? So that is one thing which we have seen, evolution of artificial intelligence, and why this generative AI actually matters in the current day, right? And right from the evolution to the AI, and till the Gen AI, right? So that evolution actually we have seen, correct? So that timelines, highlights, all these things we have covered in detail, correct? And then after that, we have seen a few areas where we have focused, or the key partners like the Google, right? Meta, OpenAI. So we have seen about a few companies, I would say, correct? Which is who is actually empowering the artificial intelligence industry. So next is we have actually discussed about the growth of ChatGPT, how it has these GPT models, right? So after that, we have actually focused on the DALI also. I've shown you an image, right? So even that we have covered, and after that we have gone to the generative AI models, right? So generative AI models we have gone, and we have there talked about GANs, right? So we have started about GANs, which is generative adversarial networks, right? And we were discussing in detail about GANs, that there are two things. One is the generator and one is the discriminator, right? So I think all of you just remember, and just giving you a quick recap of yesterday's session. So there are two things. One is the generator and one is the discriminator. And this generator tries to create a fake images. I think you guys are remembering what I'm talking, right? So discriminator is trying to spot the the data, whether the data is real or fake. So it is a cat and mouse game, right? Where the generator actually tries to create more fake images, and the forger actually tries to identify them. So what happens is, this actually happens, as a continuous process. So training, trying to create fake images, and making the discriminator identify. So this is a cat and mouse game which actually happens, right? And even yesterday, one analogy also I told, right? A forger tries to fake the paintings, and art critic tries to spot the forgeries, right? So over time, the forger gets better at faking, and the critic gets better at catching them. So this analogy also we have seen yesterday, right? So till here we have discussed. Okay, so that is what what we have talked about, especially in this particular scenario. Now, coming to what we are going to discuss on day 3, first of all, especially we are going to continue. A couple of questions I got. Orchestring, I didn't use that word actually. I don't know where you have picked it. I've not used it actually. Sorry. So no one. Yeah. This is one thing. Please be careful, guys. Even yesterday also people were asking me. One important thing. Mm, Yeah, one important thing is, please use the same email ID for all the sessions. Okay, even in the starting session, Amar sir also told you that, right? So for attendance, you have to mark your attendance through all the email, using one email ID. Don't use multiple email IDs. I got couple of, I think 2 or 3 messages today about that. So please be careful on that. Sir, we have unknowingly marked with other email IDs. So please take care on this. This is a very important thing. Okay, because you have to write the MCQ test and you have to get the certificate, right? So 30-hour program certificate you should receive after attending all the sessions. So don't be in a position where you don't get the certificate after attending all the sessions. So please be careful. Okay, it's not too late. It's just day 3. So even just a day, 1 or 2 days, if you lose attendance also, fine. You need to maintain 75%. So at least be careful right now. Okay. So please be careful on that. Okay, that is one thing, I just wanted everyone to remember. So those who are logging in the same email ID, it's fine, absolutely fine. Okay, just it's a precautionary measure, to receive the certificate. Okay, so keeping this in mind, let me continue, because we have to start with the today's agenda. All right. Okay, so let us go with the today's agenda. It is day 3, right? For that, you have to contact the admin team. Yeah. Okay. My job is to train and answer your questions. Okay. So anything which is which is regarding your mail ID and all, because many people don't know that, you think that you can log in with multiple emails. That's why I just told you this. Even that is not my my area. Okay. All right, because it should not face that issue, right? So just as a precautionary measure, I am uh, they will be there. Last 5 minutes, you can chat with them. You can see it as XLR solutions. Okay. So that with that, I think Sushmita ma'am is there today, so you can contact her. Okay. Last 5 minutes, you can contact. Last 2-3 minutes, I'll stop. Right. So so I'll ask if you have any questions. Right. So at that time, you can contact her. Okay. All right. Please let me start. Uh, no daily assessments. No daily assessment. It is only one assessment on day 15, last 45 minutes. Okay. Yeah, last 40-45 minutes, 1 hour, something like that, you will have the assessment. Okay. Hope I have cleared it out, except that receiving of emails and that, I cannot help you with that. So only that thing I cannot help you. Apart from that, anything which is in my area, I can help you out. All right. So let us continue from what we have to discuss. Right. And I was about to show you this image, and it was almost time, so I stopped. Right. But to understand, especially GANs, this is a very wonderful image. Actually, we have discussed about the discriminator, and we have discussed about the forger, right? Which is the generator. So generator and discriminator. So this is how the generator actually identifies, and actually it tries to create. Okay, so this image will actually try to help you out that what happens inside the mechanism of GAN. Okay, so here you can see that the generator is actually creating a fake image, right? And from the training samples, right, from the training data, it has taken a sample, right, and it will try to identify that image and this image, and it will try to identify that that bottom one is a fake image and the upper one is a real image. Okay, so that is the duty of GAN. So next thing is the impact of GANs on generative AI. So as I told you that how much this particular concept of GAN is playing a very important role, especially in the field of generative AI. And it is not it is I told you also that this particular area is one such area where it has actually laid a huge foundation. All right, so it has laid a huge foundation stone in the field of, particularly in the field of generative AI, right? But once the technology has actually gone through about the concept of transformer has come in, right? Then the things started to change, right? But even before the transformer as a framework has come into the existence, GAN was actually a pretty good concept, because this was a model where it is basically able to detect any images, right? So for example, different kinds of images, human faces, landscapes, right? So it is able to model different kinds of images. So models like the style GAN to big GAN, these are some of the models which are actually developed by GAN, which is generative adversarial networks. Okay, the name itself has generative, right? So generative adversarial network. So next is, it is made possible to generate ultra-realistic image from noise, a major leap in AI creativity. Now, if you think, if you think logically, and you may know what is a noise, right? So can anybody tell me what is a noise, or you can just think of what is noise? So noise is nothing but an unnecessary, things in the data, which is not required for the model to train. Okay, so that is basically called as a noise. Okay, so particularly this particular thing not only is just for the images, but also for the normal data set also, right? It is also this kind of noise, which is actually available for the data also. That means capturing unnecessary features or patterns in the data, right? Unnecessary, I would say, unnecessary features, right, in model building, where the model doesn't fit properly. Okay, so but especially in images, this actually plays a very huge role, right? So let us go to the next part, which is the catalyst for AI creativity, right? And the GANs made a revolution actually, right? One such example which actually happened in Europe, right, which is, Christie's auctioned, she auctioned an art piece, right? She created an art piece which is, using the AI creativity, and she sold for, $432,000, right? It was almost like a real painting, right? So that much of AI created images, portraits, which can be actually generated by AI creativity. So that was, this does this example doesn't mean you start creating, but that was one such example where that much of realistic art, which was actually created by GAN. Next is fashion, virtual apparel designs and try-ons, then game development. I think many people, game, right? So in games, you can see the concept of generative AI in the fields like especially in the technology called as ray tracing, right? So those who are those who game, you might be knowing what I'm speaking about, right? So you have something called as a ray tracing, right? And every graphic card has this ray tracing course, which allow use this hardware to create the realistic images. Okay, now the next thing is film and animation. So deepfakes, character reanimation, and style transfer. So I think everybody is aware of animations, right? So creating the images, making them more realistic is what can be done using the GANs. So what is the impact of this creativity? It is empowering the industries. Okay, it empowered the industry with tools to rapidly prototype or generate the novel content. So novel means, right, real content, right, original content. Okay, so it is training on the real data, and it is creating something which is not existing. That is what only generative AI, right? Next is face and object synthesis. Okay, so GAN power systems that generate faces, logos, cartoons, anime, objects, and backgrounds. So those who have actually tried, these things might be knowing, what I'm talking about. So what is the impact, especially is in the fields of entertainment, media, AR and VR is virtual reality, right? And synthetic data generation. So are you aware of synthetic data, right? So anybody is aware of synthetic data? So synthetic data is something where it's a kind of real data, okay, but not exactly real. Okay, so creating an artificial data with not just artificial information. It is not just artificial intelligence, artificial data. It is a kind of data which is very close to the real world, right? Sometimes what happens in certain scenarios, especially especially in the fields of medical, especially in the field of medical, uh, and even other fields also, because I remember using many synthetic data sets as well in certain scenarios. So especially in the field of medical, we will not have real patient data, but we know which kind of things will be which kind of which kind of thing. So we are going to generate a synthetic data. It's an artificial data which is very close to the real-time data. That kind of, sir, what is the benefit from doing this? Right? A few people might get this doubt. So what is the benefit is you can build a model for future prediction where the real data is not available. So if a particular area where you have a real data available, let us say you have a real data available, I never say to use artificial data, okay, or a synthetic data. Let us not say artificial these many times. Let us say synthetic data. So, we use synthetic data where the data for that particular thing is not available, right? So we try to create, synthetic data, okay, using proficient AI methods. We try to create it using proficient AI methods, not just simply like whatever comes to our hand, just creating it. No, it is not like that. Okay, so this synthetic data, after the frameworks like the GANs, VAEs, and transformer frameworks have come into the existence. The generation of synthetic data, right? Generating synthetic data has actually evolved, right? So it has actually evolved in such a way that, right? It has evolved in such a way that we are able to, right, do good things, okay, even in certain areas where the data is not available for us. Okay, so this is a groundbreaking achievement what has been done by these frameworks. Okay, so that is why, especially, whenever I do a session on AI, definitely when we talk about agentic, because all these AI agents and agentic AI use these GANs, VAEs, and transformers. This is the reality. Okay, so they use these frameworks to actually do a certain task. Okay, so it is our responsibility to know about these, what are powering the AI agents or the agentic AI. Okay, all right. So let us go to the next part, which is data augmentation and simulation. Okay, so okay, no questions, good. Fine. So let me talk about data augmentation and simulation. And here we can talk about the synthetic data sets, especially, I was talking about the synthetic data sets. No, in the before slide when I was discussing this, I was talking about this, medical field, right? So that is one of the areas, especially it was one of the areas, right? Medical field was one of the areas where the synthetic data sets usage was actually pretty high. All right. So, or the creation of synthetic data sets has actually, uh, use was more, or you can say the requirement was more. Let us not say, rather than saying use was more, we can say requirement was pretty high. Requirement was pretty high because not every, sometimes it was, it will be having a limited data. So especially in the fields of medical, autonomous vehicles, robotics, right? So these are some of the areas where we needed the simulation of synthetic data sets. All right. Next, in the field of advances in audio and video generation, right? So basically, these GANs actually, these can synthesize the short video clips, voice cloning, and music, deep fake video manipulation. So I think everybody knows, many of you know deepfake, right? So that has actually been a technology of actually GAN. All right. So don't raise your hand. If you have any question, you can just post it in the chat. I'll take up, during, from one block of session to the other block of session. I'll take questions in the middle. Okay. Please post it in the chat. Okay. Even if you put 100 questions also, not a problem. I'll answer your questions. But please put it in the chat. Okay. Because I just get that notifications every time that, this person has raised hand, that person has raised hand. Please, it is a bit of distracting. Please, just put it in the chat. Question, just put it in the chat. All right, I'll take it up. Okay. Let me do the session. Okay. It's only, it's almost 7:30. So let me at least do till 7:45, 7:50. Then I'll take up the questions. Okay, so emerging GAN, yeah. So these are the three things, some examples. And deepfake was one of the scenarios. It was one of the scenarios where, GAN was implemented. Many of you know, deepfake, right? The technology of deepfake. But many of you don't know that it is actually a framework of GAN. All right. So this is the main, scenario behind the deepfake. So next is impact is enabled both innovative applications and ethical challenges in the media authenticity. So this is where in the field of audio and video, right? It might be movies, it might be short films, right? It might be cloning something, it might be in the deepfake, any kind of area. Next is cross domain. So it is this one is for cycle GAN and pix to pix. So this is basically on sketch to photo, night to day, horse to zebra, satellite image to map, right? So these are some of the examples where image to image translation was available using the generative adversarial networks. So this has opened up the domain adaptation and creative AI across the scientific artists in the fields, right? So next thing is influence on model designing, right? So in the model designing also, especially GAN was able to create novel concepts. Novel concepts in the sense that means the concepts are not available in the real world, right? Just from the training data, it was able to build a model and it was able to create something which is very new, which is not existing. That is what is called as a novel concept, right? So it was adversarial learning, which is generator versus discriminator. That was the main agenda of what is a GAN. Then we have minimax optimization. So those who have studied bit of computer science or statistics, you might be knowing minimax and max mini optimization, right? So this will be inside game theory in statistics. So inspired techniques like even in just normal artificial intelligence also, you will be able to see this minimax and max mini, hill climbing, all these things, algorithms will be seeing, right? So inspiring techniques like adversarial training in other models, right? So changed how we think about training generative models, inspired hybrid architectures. So this is, don't you think all these things what we were discussing now, this we are in the seventh important impact, because I started this slide by saying that impact of GANs on generative AI, right? So these each one is one impact what has created in this real world, right? So if you are pretty much aware and you are into technology, you might be feeling the things that what I'm exactly speaking about, because these are the real life impacts what has happened after the concept of GAN came into the real world technology on in 2014. 2014 is the year GAN came into the public, or it is introduced into the public, right? So this technology has created a lot of things in the last 10 to 11 years. So next is, this is the step-by-step procedure. So these 7 points are extremely important. Okay, these are seven. These are seven. I would say breakthroughs, right, in the field of generative AI and artificial intelligence. Okay, so this is basically the structure of this kind of structure. You might be familiar if you know machine learning or you have learned machine learning before, right? So you see, as a process of machine learning also, these are the steps which actually go through a process. One is defining a problem, right? Then collecting the data, right? But here data is already a part, so we say that selecting the architecture of GAN, then train discriminator on the real data, then generate fake inputs using the generator, then train discriminator on fake data, and train generator with output of the discriminator. So this is what step-by-step process, 6 stages, what happens inside the GAN. Okay, now let us go to the next important concept. I told generative AI has 3 major, right, frameworks. One is the GANs, one is the VAEs, one is the transformer. So let us talk about the concept of VAEs. Okay, so VAEs are nothing but variational autoencoders. Okay, so variational autoencoders. So let us try and understand that what are these VAEs or variational autoencoders in detail. Okay, so just before that, so many questions. Okay. Okay, let me take a few questions. So many are there. Okay, so definition of synthetic data. Synthetic data is something which is created. It is an artificial data. Okay, it is not real exactly. Okay, it is not a real-time real data. I'll tell you why I told that sentence. It's not real-time real data, but it is like a real-time data only, because based on a few, based on a few data. See, why synthetic data is will be created, I'll tell you. Okay, then you'll be able to understand or figure it out very easily. When a huge data is not available for training, because I think you guys know that for machine learning or deep learning we need huge amount of data. For at least machine learning we need a decent sized, but for deep learning we need a huge amount of data. All right. So when this huge amount of data is not available, we have to we have to build a model in certain scenarios, right, for certain purposes. So at that time, with the limited data, right, each individual incident can be clustered into different things. And what are the possible outcomes for each cluster that will be framed as a data? So what are the each possible outcomes of that particular particular issue or a particular thing, right? The limited data. So using this limited data will be created into a huge data. This artificial creation of huge data is only called as synthetic data. Okay, so this synthetic data is used everywhere in the industry. It is used everywhere in the industry because not every time companies will have access to the data. So they will use the limited resources, whatever they have with the data. From there, they will try to build upon the artificial data. Okay, so that is why only I took this example, in GANs about the synthetic data, because this is a very important concept. And whatever these AI agents, right, agentic AI or AI agents, even train on is on synthetic data only, right? Even these train on synthetic data. So without synthetic data, there is no artificial intelligence. I can say very bluntly. Because not every time, every place, we will have access to huge amounts of data. Right. First of all, due to privacy issues, many people will not give their own information out. Okay, let us not go to data collection part. What are the problems in India with data collection or other countries also? Let us not go into that. With the limited resources, what they are having, they are trying to create an artificial data with all the possible combinations. Fine, it is acceptable. No, company is not pressurizing anybody. They are creating something which they can build a model. So if we give data, if we give our own data, right, let it be medical, for example, in the medical industry, right? So a person diagnosed with a certain with a certain features, a particular is diagnosed with cancer, right? If that particular person's information can be, if he says, okay, take my information, no problem, that because of these reasons, you just take the data, fine, hospital people will have the data. And if it can be shared out, it is fine. But if it is private, because we don't like our data should be shared, correct? So if it is a private, so how come medical companies can develop a drug, right? uh, I'm not saying that you can all give your private data. I'm not saying that, but to think logically, right, then only the medical people can develop a drug in order to for particular thing, medical problems for mankind, right? But if they don't have information, right, then what can they do, right? That is in where this generative models like the GANs, VAEs, and transformers, with the limited information what they're having, all the possible combinations it will generate, and it will try to generate an artificial data which can be trained. Okay, sir, is this 100% successful? It will not be 100% successful, obviously. Okay, so that is why you will be seeing side effects of medicines for patients, or a treatment doesn't go well for the particular patient. Yeah, those are different problems. Let us not go into the medical field right now, but especially why I'm telling is this is mostly done in the field of medical. Medical mostly they are going to do. Why? Because that is how the pharmaceutical companies can actually develop a drug with a synthetic data set. GAVA and Transformer, three of them are used. One of them is used on creating an AI model. All are used. What's the name? Upsar. So all of them are actually used. Okay, everything is very important. All right. All of the models are extremely important. In certain situations, which kind of model is very important? That actually these are architectures. Okay, that particular architecture or model is actually used. Okay, to answer your question. So deepfake video is basically identifying a fake video. Okay. So it was actually very popular for a bit period of time. Okay. Now I don't see many people talking about deepfake, but this was one of the this Instagram, Facebook, all these use this to identify what is real and what is fake. And to identify this deepfake for what is real, what is fake, they are using GAN technology only. That is what I'm telling. We use this, but we don't know that it is GAN, that is VAE, that is transformer. That we don't know. That is what I'm actually trying to tell you. Okay. Uh, okay, sir. Okay, thank you so much. You said okay, sir. Okay. Yogesh, I'll share the slides. Okay, don't worry too much. I think you're taking any photographs or something. I don't know. It will be shared with you in the LMS. Please don't worry about that too much. Any one particular concept you feel you didn't understand or something like that, you can, yeah. Thank you so much. Please let me continue. Okay. All right. So let us talk about the next concept of VAEs. Okay. Let us talk the concept of VAEs and what is the core idea behind implementing a VAE. Okay. So VAE is basically relying on a particular technology called as encoding and decoding, right? I think many of you guys know that what is encoding, what is decoding, right? Especially those who edit the videos, right? You might be knowing exactly, but this is bit of different. Okay. The concept is basically following that encoding and decoding the same thing, but what happens in variational autoencoders is bit of different. Okay. So in autoencoder, the main thing what happens is the reconstruction. Okay. Here if you can see that the architecture, the step-by-step procedure is basically input, it encodes, then it has something called as a latent vector. I'll explain to you what is that latent vector. Then we have a decoder, and this decoder will reconstruct the output. So this is the step-by-step procedure, what happens in a simple way for a variational autoencoder. Okay. So the applications in the industry currently are the anomaly detection, right? So anomaly detection is nothing but anomalies are nothing but the unusual observations in the data. Okay, something which is completely out of the ordinary. Those are basically called as anomalies. Okay, the next thing is the generative design, right? So creating new product architecture prototypes, then denoising and compression. So noising, about the noise, I already told you what is noise, right? So it is basically the abnormalities in the data, right? So blurry images, right? Something which is not exactly the correct pixel, which is not being captured. Basically, those are vectors inside. To see an image, you have a matrix, or you can see a vector behind the image. That is how computer actually takes the images. All right. So the reconstruction is not done in a proper way. You can see noise in the data out. So this is what actually happens. So this is the architecture, or this is the main, I can say in a very simple terms. I don't know how many of you are able to pick it, because it's a proper deep learning model. Yes, it's a proper deep learning model with a lot of hidden layers. Okay, and the connections between the independent variables to the the encoders in between, or you can say the hidden layers. Basically, they are hidden layers. Okay, so A1. So in the encoder, you can see A1, A2, A3, A4, right? In the decoder, you can see the A1, A2, A3, A4. These are basically the hidden layers. So functions between these hidden layers are basically called as activation functions. Okay, and latent state distributions, here you can see, right? I talked about the latent vector. So latent vector is nothing but the mean and variance. So those who are aware of statistics, you might be able to follow what I'm telling. So in statistics, we have we normalize, right, mean and by using mean and variance method. So we do it mean as 0 and variance as 1. So this will be done using the distributions, sample form of distributions, particularly the normal distribution. Okay, and between the between the input and the hidden layers, the connections between these blue lines are basically the activation functions. Okay, so a collection of activation functions clubbed together using the latent state distributions and using the sample distributions and statistics, right? The encoding happens the same way. The decoding also happens in the same way. Okay, encoding is done by mean and variance. That encoding will be decoded using the sample distributions. So this is the main agenda. So it's actually a proper mathematical and statistical model. Okay, so of course, all AI models are that only. That is a secondary thing, right? All the deep learning models and machine learning models are that only. But especially these VAEs use this methodology. So next thing is the tag or the title name, especially for VAEs, is the compressor and the rebuilder. The compressor and the rebuilder is what the name is given for the variational autoencoders, right? The idea behind this is a neural network compresses input data into a smaller formats, which is basically called as an encoder, and then it tries to reconstruct the image, correct? So it learns how to generate new data by sampling from the encoded space, right? So more stable than GANs, but usually less sharp in image generation. So when you see, GANs is the first level. After that, next you can see VAEs. After that, you can see the transformers. So obviously the VAEs are much better than the GANs, and transformers are much better than the VAEs. So because you already know, right, from one generation to the other generation development, obviously they use all the things which, see, VAEs are developed as an advancement level of GANs, and transformer is developed on the advancement level of VAEs. Up, at the top of transformer, there is nothing. Transformer is only ruling the world actually in the architecture for AI. Okay, so to understand what is VAE, a machine that can learn to compress and decompress images while learning the essence of them. That is very important, no? Right? So next is, the core idea basically is to learn the essence by compressing. VAEs are generative models that work in two main steps. One is the encoder and one is the decoder, right? So compresses encoding like an image into a small dense representation like the latent space. That is what I showed it in the image as well. So the latent space tries to compress that is what encoding is about. Okay, so this will be decoded using the reconstruction techniques. All right. So what makes VAEs special? Okay, so I told compared to GANs, VAEs are more, I would say, developed or advanced, you can say, uh, or we can say that it is like an upgrade. It is an update. Okay, so whatever you want to call, you can call. It is not a problem, right? It's like an upgrade. So they don't just memorize inputs; they learn patterns in the data. That's what I was telling you. For encoding and decoding, it has to understand the patterns in the data so that it is not able to capture the noise. If they don't understand the patterns in the data, if they don't understand the nature of the data, it will not be able to capture the real essence. It is going to capture along with the noise. So this will be a very big problem when it is deconstructing, or it is constructing it back, or it is doing the reconstruction part. So by sampling from the latent space, they can generate new and similar data. Okay. So typically more stable and easier to train than GANs, obviously. So but generated images may be blurry or less sharp compared to GAN outputs. Okay, because this is much faster compared to GANs. But if you're able to build a model without the you can say without the capturing of especially this noise, right? It will be a very good image, especially when we are using the VAEs. Okay, so what is the use case is generating new handwrittens, right? So I think many of you know this MINS dataset. It is that's why I've taken this use case also, because it's a handwritten digit. Okay, and this data set has a lot of real images and a lot of fake images also. So this was actually a very famous data set, right from I think maybe last 10 years. I say because definitely you would have come across this MINS data set, which is actually a handwritten digits, which is used for training the images in computer vision. So simple analogy is, imagine a smart zip file machine. It compresses image to find the essential patterns, then rebuilds them from those patterns, and can even create new images using what it has learned. Okay, so that is what the main analogy and system about the VA is. Okay, so this is one more image about the VAEs, variational autoencoders. So it uses the probabilistic encoder and probabilistic decoder, because we're using mean and standard deviation, and it is using distributions. No, obviously it is a probabilistic, it's a statistical concept, obviously. So it will be a probabilistic, kind of concept. So it will be encoder and decoder for probabilistic. So next, one more image also. Okay. So these are a bit complicated images for people who are completely from non-mathematical or statistical background. Because if you are into data science and generative AI and artificial intelligence, especially bit of math and stat is very much required, because most of the concepts have math and stat in it, right? So it is bit required at least. Okay, I'm not saying to study entire math and stat, but at least what is required you have to learn. Okay. So this encoder and decoder basically uses the conditional probability. Okay, and for reconstruction of images, it is going to use something called as a reconstruction loss. Okay, and KL divergence. Okay. Okay, so let us go to the impact of VAEs in generative AI. Now we have seen what is a VAE. Now let us see how VAEs are actually impacting in generative AI, right? So after that, let us go to the transformer. So before that, let me take questions. I think a few, 3 questions I got till now. Okay. All of them are generative AI architectures, right? Absolutely, Apsar. They are generative AI architectures. And all your agentic AI and AI agents also use these architectures. That is why only I'm teaching. Yes, absolutely. So all the AI agents and agentic AI machines, everything, everybody uses these 3 architectures. Without GANs, VAEs, and transformer, there is no agentic AI and AI agents. Okay, I think that should clear your doubts. Okay. Let me. This denoising. Denoising means uh, removing the effect of noise. Removing the effect of noise is basically called as denoising. Actually, what happens is when we try to remove the noise. Okay. Some of the time we are successful. I think definitely. I don't know. Maybe you don't know machine learning. You have not learned machine learning or deep learning. You will come across the terms like noise and all. How to remove that? How to capture? if I have to go there, it will be out of the box, because we have something called as overfitting and underfitting. From there, the entire thing starts. So it is related to machine learning concept actually. Uh, that will be a bit out of the box. That's why I'm not talking about that. So zip file is nothing but a RAR file. Okay, a smart zip file can actually generate few things also. So any questions? Noise is the sound of black and white images. Black and white. No man, this is different. Noise is different. I think you got confused. Why I will talk about the sound about TV and all. This is an agentic AI session, no? No, noise is basically the disturbances in the data. Okay, so when a model has been actually built, I'll just put it again. Okay, a few people are having a few doubts. It is basically, capturing the unnecessary things. Let us not use technical words only. Let us keep it very simple. So to for example, right, to achieve a certain goal, right? So what do? You do certain things which are only necessary to achieve that goal. Correct? Yes. So if you also do unnecessary things to achieve that goal, right? That unnecessary things will stop you from reaching your goal. Those unnecessary things are only noise in the data. That means something which is not required for predictive analytics, something which is not required to build a model, right? Which is not suitable or enough, or which is not good for building of a model. All right. That particular thing is basically called as a noise. Okay, it is not good and it is not required. So whatever noise is there in the data, that has to be removed. That should not removed exactly. It should not be considered for building a model. So if we do that, we are going to build a very good model. So it is like that. All right. So let us go to the next part. So any other questions? That's it. Okay. Okay. All right. We'll do one thing. Okay. So let us just go for a short break and come back. Then after that, we'll see the real life applications of what is the impact of VAEs on generative AI. Okay. Can you explain the diagram once again? I'll just come on. Yeah, after the break, I'll explain it again. Okay. All right. So welcome back to the after the break. Welcome to the session. I can see questions. Nice being used to discussion model. Just awareness. Not exactly, man. That is different. What you're speaking and what I'm telling is different. Yeah, diffusion models. Let us not talk about that. That is again in the. I didn't get the question properly. Can you just reframe it? Explain all section. Who you explain noise. What is it exactly? Okay, actually, one person was asking. Just explain the image. So before you know, so let us first understand the image. Then we'll go to the. I think a few people have that doubt. Okay, because a couple of people have asked that. So see this image. What I was showing you about, especially. This is a very simplistic image. Okay. So a bit of complicated image I've already shown you before, right? So if you just go back quickly, yeah, this is a complicated image. This is the entire structure of actually a VAE. Okay. So this image is the big one. This is basically a simplified one. This is basically a simplified version. All right. And this is also a bit simplified, but this consists of formulas actually. Okay. So leaving formulas apart, what exactly is this basically trying to do is it is trying to encode and decode. In this process, it is going to apply for encoding one procedure and for decoding one procedure. So for decoding, it is applying a particular function which is using the sample distributions. That is only this Z function. Okay. For encoding, it is applying the mean and the variance technique. Okay. So that is what the whole picture is. Okay. Let us see the impact of VAEs inside generative AI. Okay. So how inside generative AI, this VAEs are actually used, right? So the first thing is pioneers of deep generative modeling, right? So VAEs are one of the first neural architectures to successfully learn probabilistic generative models of the complex data, right? So introduced with the idea of mapping inputs to a latent space from which data can be sampled and reconstructed. I told you, it is completely a probabilistic method, or we can say a statistical method. Okay, so neural network, in a sense, it is consisting of neurons. That is why in the first image you have seen that there are deep. I say that deep layers. There are a lot of layers. I told, right. Something which has layers is basically between the input and output. If there are certain layers, that is basically called as a neural network. Okay, so what is the impact of this generative model? Open doors for probabilistic modeling in deep learning, right? Layering the groundwork for many modern generative techniques. And this many modern techniques, generative model techniques, especially to the model, especially which is a transformer. Especially in the building of transformer, this uh, has created a very huge impact, on building such a model, right? So next is latent space interpretability. Okay, so there is something, basically what happens inside the VAE. I just told you through the images, okay? Because rather than like this text, it is easy for you also to understand through images, right? So that is why I just showed you the images also of VAEs, okay? And I also told how the encoding and how the decoding also actually happens. Okay, so VAEs basically learn the continuous smooth latent space. I think many of you might be knowing what is an interpolation. Okay, interpolation is nothing but finding out the values which are already which are not existing based on the other data. So based on the rest of the data points, finding the value of the data points which are missing is basically called as an interpolation. So between the data points, interpolation technique was actually found by Newton. Yeah, Isaac Newton. I think everybody knows Newton, right? So Newton was the many of you know Newton as a scientist in physics, right? But he was actually a hardcore mathematician. Okay, those who actually love mathematics will have the interest in physics and computer science and all. So he was actually a hardcore mathematician. He found a lot of methods in mathematics as well, and one such method, which is till date is used, is interpolation. Forward interpolation and backward interpolation. This concept was given by Newton. Okay, so next is the clustering method, and clustering is nothing but grouping similar points together is what clustering is about. Then manipulating generative attributes is what the other thing is. So what is this latent space interpretability has actually done to the variational autoencoders? So it enables the controllable and interpretable generation, especially valuable in the research of art and medical imaging. I told with medical, the concepts of AI, generative AI, agentic AI, AI agents, everything, it is more helpful. It helped the field of medical more. One such field where we can think of is especially in the field of medical. Okay. So next is applications in generative tasks. So while not as a headline grabbing as GANs or transformers, VAEs are used in, right? So I'll come to the transformers part later. But basically, the VAEs are useful for image generations and editings, and molecular generation, and anomaly detections. Right? Anomalies are abnormal activities. Okay. And the first point in anomaly detection, you can see learn normal data distribution. I think those who know bit of those who have a bit of background on statistics, they might be knowing about this continuous probability distribution, which is normal distribution. Okay, so that is the foundation for this VAE, variational autoencoders. That's why I told it's basically reliant on mathematical and statistical concepts. Okay, coming from there, the molecular generation is drug discovery using the VAE-based latent space optimizations. Then speech and audio synthesis, learning how to compact representations, right? Then the text modeling, right? So basically, it is used for sentence interpolation and disentangled representation learning. Now, what is the impact of, or what are the entire applications which you are seeing? There are only few applications I've put. If I have to put many, it will be so many slides of just the applications. So niche but impactful in scientific, creative, and industrial applications. Right. So it has been used, or it is being used in multiple areas where we can actually, follow the using this framework. There are a lot of developments and advancements. Next is foundation for more advanced models, right? The models like the vector quantized VAE, DALI, right? So now the applications, some of the applications which you guys know, you can see jukebox, right? So all these are products, byproducts of VAEs. Okay, so conditional VAEs as well, used for controllable generation and disentanglement. So diffusion models. So one person was actually asking as well, right? So because in a few diffusion models, the formulations of VAEs are actually used. So what is the impact that this has done is it served as a building block for more scalable and advanced generative systems. So that is why I told GANs and VAEs were like a strong foundations which has laid path for the growth of generative AI and the advanced models which are actually used in big models like the transformers. Transformers is what revolutionized the industry of generative AI. All right, so you can post your question in the chat. Don't raise your hand, please, because we cannot communicate through voice. So if you just post it in the chat, I'll be taking up. Okay, let me check. Okay. So LSTM, I'll come there. Never heard of Newton. Okay. Wow. That is that is shocking. Okay. You can just Google Isaac Newton. Okay. Okay, if you have not heard, fine. He's a one of the great scientists. So you can just Google it. Can you define interpolation? Interpolation is a method to find the missing values. It's a pure mathematical concept. Diffusion model, I'll come there. I'll come there. I'll come to the diffusion model. Um, I think it is your problem. From my side, it is absolutely fine. I don't know what's your name. It is just showing user. It is from your end only. Just log it out and log in. Log in and log. Sorry, just log out and log in. From my end, it's absolutely fine. Please post it in the chat. Please post your question in the chat. I don't know, even after telling you guys are raising your hands. Please post it in the chat if it doesn't go. See, you can't expect me to answer only the questions. No, please just try to understand. Okay. So I have to teach something also, right? So I'm here to train you guys. So continuously I cannot answer questions. So please understand that. So once in a while in the middle, I'll take up the chats. Okay. So once you post the question, don't expect me to immediately stop my session and just answer your question. Uh, that is highly not possible, guys. Kindly understand it. Okay. So all right. So please let me continue. All right. So these are the foundation, stones for, or I can say the building blocks, especially when we are actually, the advancements, what the generative models or generative systems have actually seen, right? So next is the research contributions, right? And since the VAEs offer, the first line you can see that. So VAEs offer a principled probabilistic approach to generation with a well-defined mathematical foundation. So used heavily in academic and theoretical research to explore latent variable modeling, variational interference, inference and regularization. Okay. So a lot of research has also been done, in this area as well. Actually, 2016, yeah, 2016 was the year. I think because 2014 was GAN, 2016 was VAE, I guess. 2017 was the launch of a transformer. So immediately once the GAN has come, the advancement started to, the research and development and the advancements started to flow very quickly. So we can say the first generation, the first advancement in generative AI was GAN, then it was VAE, then the third advancement was transformer. So once the GAN has come, immediately within 3 years, you can see the second advancement as well as the third advancement, what has actually happened. So all these actually happened very quickly. All right. Next is, let us see our our superhero. Okay, he is the superhero of the current generation. Okay, so if you know about transformers pretty much, okay, why I'm saying as superhero, if you know about transformers, you will agree with me that he is the superhero of the current generation. Okay. So if you are very new to what is a transformer, okay, you might be knowing, sir, why sir is calling. Okay, so if I say transformer, there are two other things people will think of. One is the transformer, power supply grid transformer, and the other thing is the transformers moving. Okay, both are not related to this at all. Okay, they are different. This is a third kind of word. Okay, so transformers movie and transformers power grid. Okay, so those two, forget about those. Okay, we don't need those. Okay, what we require, so there is a particular word called as a transformer inside the concept of artificial intelligence. So you can remember that. All right. Yes. So this major breakthrough in technology, which is called as a transformer, this was introduced and this was researched and found by the Google's brain team. Okay. And this technology was actually launched by one of our most famous companies, which is Google. All right. So 2017 is the year transformer was introduced. So transformer is a 8-year-old technology only. That is why now we are in the second generation transformer only. Okay, so advancing the concept of transformer, even the researchers are finding very difficult, even at Google, and even Nvidia is doing a lot of research on the technology of a transformer. Even Nvidia is doing a lot of research. Okay, so on this particular technology of transformer, because they are using this transformer technology in their graphic cards. Okay, so all the RTX technology which they have actually come across, the graphic cards, those who game, you will be knowing what it's not just for gaming only, it is for powering the generative AI chips. Okay, so if I say gaming, a lot of people will think, okay, so it is not related to us who doesn't game. Okay, absolutely not. Whatever powers the generative AI, right, the computational speed or the computational which is required, everything, every hardware is actually provided by the company Nvidia. They do the research, they do the advancements, they use this transformer inside their RTX chips, RTX graphic cards, ray tracing graphic cards. They use in their technology because all the RTX graphic cards are equipped with the technology of a transformer. Okay, so this is one thing. Those who are aware of Nvidia, those who are aware of what is I'm speaking about, CUDA cores, ray tracing cores. Now we have 50 series graphic cards being launched, right? So all the 50 series graphic cards use the second generation transformer. They all use the transformer architecture for generative AI. Yes. For all the AI tasks, you buy graphic cards and you use it, but you don't know. But they are equipped with the technology of transformer. If you are buying an RTX graphic card, it is equipped with a transformer. So without your knowledge, you are using a transformer. As simple as that. Okay. Yes. They use a technology called as deep learning super sampling, which is called as DLSS. Right. So DLSS use these technology of generative AI, which uses the technology, the framework of the model of a transformer. Right. It does use the deep learning models. Yep. Okay. So let me continue with the let us we should actually talk about, and we should also understand that what is powering everything what we are actually doing, right? So what framework is actually powering the entire AI task, what we are exactly kind of running into the real world, right? So the first one, so the core idea is basically, as I told you, it's about Google, and the most important aspect of a transformer is self-attention. Or we have one more word which is used for this. This is called as a attention mechanism. attention mechanism. Here I've not mentioned, but it is relying on the technology called as attention mechanism. Attention mechanism. So what is this attention? Attention in the real world means giving importance to something, to a particular context. Understanding the individual context, understanding a certain context is called as attention in the meaning of a transformer. Okay, I'm not saying attention is different from the real world meaning. It is different here. It is giving a particular importance to a particular context is what attention is. Yes. So that is why I was telling you also, when you use ChatGPT, you are giving a prompt. That is not question and answer also, I told you. You remember, it is a prompt. You give a prompt and it gives you the answer for a particular prompt. So I also asked you how your ChatGPT is understanding your prompt. It understands using this self-attention or attention mechanism. This was the answer I wanted to tell you, because after this concept has come, because the chat GPT what you are using uses transformer only. It uses a transformer. So it GPT, I told generative pre-trained transformer. If you remember, you'll able to link what I'm telling. So it uses the transformer self-attention or attention mechanism to understand the context what you are asking. It will break down the context and it will understand, and it will try to give you the reply on that particular prompt what you have given. I think now everything what I asked, what I'm teaching, I think a lot of people are able to link it. Yes, you're able to link it now. Now, next thing is the architecture highlights. So as I told, this is actually based upon something called as self-attention. All right. Then we have positional encoding. All right. Then we have the stacked layers. All right. Then we have the applications we can see. Okay. Stacked layers are nothing but layers which can be stacked. So stacked is nothing but one layer after the other. So it's a deep learning model. The layers can be stacked one after the other. So it's a deep learning mechanism. I told you also, these transformers combine with the deep learning to produce results. All right. Next is the applications. So yeah, text summarization, translation. Yeah, there are hundreds of applications. Not even hundreds, thousands and lakhs of applications of a transformer, because transformer is what actually powering the AI in the present day. In one simple line, I have to tell. So you take any example, it is a product of transformer. So code generation, image generation, text summarization, text understand, every application is a transformer. Now, I think, the dots of the puzzle are, connecting for you guys, right? So next is, what is a transformer in generative AI? Okay. And, the transformer architecture is found by a person who is of Indian origin. Okay. So his name is Vaswan. Okay, he's of Indian origin, but actually he was settled in the United States. Okay, because he's working for Google, right? So it is found by Google, right? So he works in the Google's brain team. Okay, he is a product of the Google brain team, which is managed by Sundar Pichai. Okay, so in that team we have one genius, one deep learning architecture genius. Okay, which is a transformer. That is why, since a transformer is a deep learning architecture only, that is why only the NVIDIA graphic cards, they use the DLSS, which is the deep learning super sampling technique, to build their graphic cards, which uses the transformer. I think now one by one it is making sense for you. So he has researched with the title "Attention is All You Need." So, when you read this title, you might not understand, but attention here is the self-attention or the attention mechanism. Okay, so it revolutionized NLP by replacing recurrent architectures, RNNs and LSTMs. Okay, so before the transformer came, people were using the RNNs, which is recurrent neural networks, and LSTMs, long short-term memory. LSTM is long short-term memory. Okay, so before the transformers has been introduced into the real world, we were using in deep learning, we are using the RNNs and the LSTMs. Okay, so once the transformer technology has come, this RNNs and LSTMs we have not completely abolished or we have not stopped using, but you can use a transformer in the place of RNN and LSTM. So why to use RNNs and LSTMs, right? When we can use a transformer. All right, so it is like that. So next is the most important components inside the transformer is the self-attention. So allows the model to weigh the importance of different words in a sequence relative to each other. So that is why I told you in ChatGPT, the prompt it will actually try to understand and it will try to give importance to each words. It will give the attention, right, importance to each words, and then it is going to use that word and then it is going to generate the output. So multi-head attention enables the model to focus on different parts of the input simultaneously. Then we have the positional encoding, which is injects information about word order as transformers don't process data sequentially. Okay, it breaks down the data and it will process simultaneously. It doesn't process in a sequential order. It just process in parallel systems because it is a big data technology also. So feed forward layers, adding the nonlinearity and depth to the model. All right. Then we have the layer normalization and residual connections, stabilizing and speeding the training. All right. So next is this is the main architecture of a transformer. Okay. So you can just see this image. In the meanwhile, I'll just take some questions because as you guys know, questions are, oh my God. Be like this. Thank you so much, man. But this is not for this is not the session in the middle. I cannot take compliments and I can appreciate you. At last, probably we can do. Thank you so much. Yes. So sure, 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 sure. Sure. I'll definitely think on that. Okay. Let me take the questions which is related to the subject. Okay. So let me answer the questions. Optimus Prime. Oh my God, Habib. No, no jokes. Okay. I know that is what I was telling when I started the Transformer. People will be thinking those who are Transformer fans, Transformer movie fans will remember Optimus Prime and all these things. Okay. No, that Transformer and this Transformer are different. Okay. Probably I would not deny you 100% because I'll tell you something. The transformer concept has come in the year 2017. It was I think 2006 or 2007, something like that. 2006 or 7, something like that. The Transformer movie was released. So maybe this fellow Vaswani would have used that particular name. I cannot deny that, but I should directly interview Vaswani and ask him that. Maybe probably in any interview he would have told, I don't know. Maybe I'll search for you, Habib, and let you know. But I don't know. He might have used. I'm not denying it 100%. But to understand about transformer, let us not go into that because this transformer is different. Okay, so this is an architecture. Actually, it's an architecture for deep learning. Okay, so let us keep to the concept. Let us not go to the power grid transformer or a transformer movie. Okay, yes, that is why only I told, because people will go, thoughts will go there. Okay, I know, students' mindset. Okay, so how does the chat GPT replies fast? Yes, very good question. I think this is a valid question. Okay. Even though it is a very silly question, but in a silly way also it is a very good question, Manasvi. Why? Because I'll tell you, when we actually give a particular prompt, okay, so it just thinks for some milliseconds to second, isn't it so? Yes, it just thinks. Okay, sometimes it thinks for some 3-4 seconds based on your prompt. Sometimes it thinks for your milliseconds or a second, right? In that process, the transformer will take action. The transformer will try to understand, it will do the sampling, it will try to understand the context, it will break down. See, what does the transformer do is, for example, if you ask the similar question, let us say you are asking the ChatGPT only, how does ChatGPT reply fast? Let us say you are asking ChatGPT only. Okay, so what it will do is it will cut into pieces. Okay, how does ChatGPT replies fast? It will identify keywords. Okay, so how does all these things are in NLP language are called as stop words. I don't know if you have studied NLP, you will be understanding what I'm telling. They are called as stop words. So what it will identify is, it will identify the keywords which is very important for the context. Yes, so like the keywords like the ChatGPT reply fast. So ChatGPT reply fast, using these 3 words it will try to generate the output. That job is done by transformer. Yeah, that's why I told, in a silly way it's a very good question, because this is very important, because many of you guys don't know that at the back end of generative AI, what is actually performing or what is actually taking over. The transformer is actually doing this. So it will identify in this image also, you can see what I'm telling you about, you can see into the image. Probably even if I don't explain in detail, you might not understand much, but you can see it will process in multiple blocks, and it will remove the stop words. That is all part of NLP. It will try to remove the words which are stop words, and it will try to identify which are the keywords, and it will give the attention. That is why I told it's an attention based mechanism. It will give attention to those keywords which are required to take over to generate your answer. That is how things work. So what is NLP? I expected this question from somebody. I got it. So NLP is natural language processing. Okay, natural language processing. I think I told you about NLP in the first session. Just a brief, at least I think just briefly I told. NLP is basically a language which is used, right, to make the machine understand what we are giving. It is a language which is used to communicate between us and machine, you can say. Or you can say, you can think like this also. It is a language which is, we are making the machine to understand us. Okay, so natural language processing is a very, 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 very important component of the deep learning models, especially in the generative AI and AI agents. Okay, see, I think Alexa, voice assistant, and everybody knows. Even though you have not used, at least you would have seen in ads or in your friend's house. So you would have used Alexa. Alexa takes your commands based upon your English word, English sentence. Let us say it's a sentence. How many of you know? How many of you actually know? Okay, don't bluff. Just answer to your heart. How many of you actually know that when you're actually talking to a voice assistant like Alexa, even the grammar is important. The subject predicate you study in school, remember, subject predicate, verb adverb, all these parts of speech, verb adverb conjunction noun pronoun, all right, and the grammar in a sentence or subject or predicate. How many of you know that it is important for the voice assistant to use a proper grammar? If you use only proper grammar with a proper subject and predicate only, your voice assistant will understand. That is only NLP. Yes, because it is trained in such a way you have a concept, parts of speech tagging, you have tokenization, you have stop words, all these things are there in NLP. You actually try to find, you train the words based on grammar also. So that is why if you speak a sentence without a proper subject and predicate, it will tell that I'm not able to understand your query. Yes, that is why NLP is useful. Okay. And the entire, it's an AI agent, right? It's an AI agent. So it is using NLP, right? And it's actually, it has been built on the model of a transformer, because it will convert the voice into text. It will convert into text, speech to text. There's a lot. Okay. So if I have to, go there, that is another, aspect, another side of what is artificial intelligence. There are so many things. That is why I told, it hardly a life is sufficient, to learn AI, what has been developed in a short time. It is so much is there. Okay. Good. You have asked NLP, maybe probably you'll be, doing your research also. Try to learn, it's good. Okay. Sorry for the previous question, but ChatGPT reply correctly every time when we asked. You said it takes only keywords. That is based upon the kind of. That is why, to answer your question, I just told. I think one girl was asking. I think Amara. Yeah, she was asking that only NLP, and the answer for what I've answered for NLP is the answer for you only. Same thing I'm telling. You have to follow the subject and predicate. You have to follow the grammar. You have to follow the grammar. Okay, I think now you guys are remembering. Oh my god. Oh, that is why English grammar, English language is very important. We learned in school. It is important, especially when you have to deal with an AI machine. English is very important. English is very important. The framing of a sentence, that only we teach in prompt engineering. That is what I told you. How to give a prompt with a proper grammar, with a proper, following of subject and predicate, because models are built like that. So you have to follow the rules, right? So yeah. Moving on from this question, sir, grammar is fully important for our daily life. Yes. So if you take like that, also it is very important. Absolutely, it is very important. Yeah. And especially when you are dealing with AI, grammar is very important, because the NLP and whatever generative AI models, everything is running on, NLP. I'm not saying everything is on grammar, but it runs on NLP, and obviously, uh, you know, it relies. So I'm not saying, okay. All right. Next question. Oh my God, so many questions. Attendance link is shared. Please check the main chat for attendance link. Don't ask me attendance link. Okay. Any subject related questions you're supposed to ask me. All right. So what is jukebox? Jukebox is nothing but a collection of certain things. It's called as a jukebox. Okay. So it is basically used for audio and video. Audio especially. Okay. Sir, yes, sir. Even I have similar doubt. It's like reply as in prompt. That means we'll be asking the go. It replies the same. The same we asked. Uh, we ask in Telugu. It replies the same. The way we ask, reply as same. I don't know, but multiple languages, I'm not sure. But English language, it is because of the transformer. It uses any language. It uses that. So Google Translate. Now, wherever you see Google products, you will see the transformer in action, because all the patent rights, the king of transformer is Google only, because he is the founder. He is the so he can use everywhere. Yeah. Okay. He's even using in the Google search also. What happened? Just came out. Okay. Let me share my screen again. I think it has come out. Probably I'm answering so many questions, no? I think the screen sharing is stopped. Okay. I don't know. These many doubts you have really. Oh, decoder is nothing but to decode it back. That means reconstructing to its original form. Something which can be reconstructed to its original form is basically called as a uh, it has been shared. I don't know why you're saying that. It has been shared. All right, I'm just putting it here. Okay, it's been shared actually. It's been shared. Um, just check it, guys. Just check it. I've shared it again. Okay. One person was asking something. I'll share it later, not now. It is actually working. It is working, guys. Just check it. Okay. Um, just check it. I think it's working. Okay. Then fine. Okay. So let me just share it back. Okay. Uh, yeah. Actually, I have not stopped. It stopped. Please just give me a minute. It's not NLB. It is NLP, Natural Language Processing. Somebody answered your question, Hemchandra. Uh, so doubts come only when we are understanding. We have a lot of doubts because we are understanding everything point by point. Okay, it's good. It's good that you're saying you're understanding. I'm absolutely happy with that. Please explain LSTM why it's or it was used. Okay. In the further classes, we can going to build an AI agent with transformer architecture. Yes, you are going to build an AI agent with a transformer architecture only. I will teach. I will just teach also a bit of GAN and VAEs also, because it will be easy for you to catch hold of a transformer. It is like transformer is like. Directly after learning ABCDs, learning going to 10th class is, it is like that. If you directly go to a transformer, first you have to study LKG, UKG, first class, second class, correct? No? Same way, you have to know about GANs and then VAEs. Okay. Then only you can learn about the transformer, unfortunately. Okay. So it is a step-by-step process. Please understand that. Okay. I could actually directly teach transformer, but it will be bit of sophisticated. So we'll do GANs and VAEs, then we'll go to the transformer. Okay. Then after that, next questions. Yeah, I've shared the attendance. Please check. Oh my God. Sir has shared. I think ma'am has said. Sorry, ma'am has shared. Please. Oh my God, guys, please follow the link. Don't ask me attendance. How are these model trained? Where are they trained? How engineers feed information? That I will tell you. That I will tell you because we'll be doing the practical part also. How these things happen in reality, I will show you also. I'll show you guys. Just please wait. So that one you have to wait. Okay. Uh, So just want to know when we will be starting the hands-on part, creating of an agentic AI applications. You have to be a bit patient on that also, because first of all, you should understand the concepts in detail. Okay, then only you can process them. Okay, so on that aspect, you can please wait. So link is working. Yes, link will work. Please, guys, it will work. Yes, you will be building an AI. Uh, an AI agent using the transformer architecture. Yes, absolutely. All right. So let me. Oh my God. Let me continue, guys. Please, 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 please. All right. It will be shared to your LMS. Notes will be shared. Guys, please wait. Uh, okay, thank you. But let me continue. Okay, please. Okay. All right. So let us see the main, main things. Trying to understand the transformer architecture. And here you can see one image. I think there is one more image also. I'll show you, which I have kept. Yeah, this is a bit complicated, but let us go with this only first. That's why I put that image in the first and then that image in the second. Okay, so let us talk about what does a transformer actually do. Okay, so it actually uses the technology of what a VAE actually uses. Okay, but I would say, but I would say in a very simple language that transformer does better, does better actually compared to the a normal VAE. Okay, so compared to a normal VAE, a transformer actually does a better job. Okay, so what better job it is going to do is this aspect of how it uses the encoder and how it uses the decoder part. Okay, so instead of using the probabilistic methods, it is using things on natural language processing. Okay, so it is using the things on natural language processing, like the tokenization. So tokenization is nothing but giving tokens to words. That means, each individual word will be given a token number, right? For example, one person was asking, how does a chat GPT reply so fast, right? So chat GPT will be given number 1, right? Fast will be given 2, right? So like that, we give it gives tokens to each words. That is what basically is the tokenization. And as I told, it uses the models, right? There are so many models inside NLP. All those architecture it is going to use. If I dig into NLP, that only will take a lot of things, and this will become more of an NLP session than an agentic AI session. So it is good to learn NLP for transformer, but this is not the right platform because we are supposed to discuss about the agentic AI. Okay, so only a few things which touch upon what we are discussing. Only I will talk about those. Which is relating to NLP. Let us not go too deep, which will deviate us from what we are doing. So please let us not do that. There are something called as a key value and a query. So this is the architecture, this is the mechanism in which it is basically following. Okay, so it is going to take the input and it is going to convert, remove the stop words, convert into tokenizers, right? And it is going to use the model which it has been inbuilt, and it is going to understand the context. For that understanding of the context, it is using the self-attention mechanism. Okay, so this is the overview in a very, 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 very simple way, so that you can understand it very easily. Okay, I can also go with a difficult approach, but you know I don't want you to feel the difficulty, because this transformer implementation also is a bit difficult. I'll show you that also in the coming sessions. But trying to understand the transformer simple way first of all is very important. Then we can go with a bit of complicated approach. Okay. So next is the architecture. It is going to use the encoder, decoder, and an encoder decoder architecture. So just the encoding is done for only the classification tasks. Something which it has to generate, it is going to use the decoder part, like the GPT. So all the GPT models, which is generative, pre-trained transformer, all of them use the decoder method along with the encoder. Techniques like BERT. BERT is a bidirectional approach which is used in Google search. Okay, Google search, it is a classification technique. Yes, it's a classification technique. It is not generating anything. It is just classifying. So that is why BERT uses only the encoder but not the decoder. Okay, encoder, decoder, you can see in translation like the T5 BART and all these things. Okay, so let us do one thing. Okay, so let us just stop here. Okay, it's almost time. So I think someone has posted the registration link. Oh my god. It runs in the cloud and that is connected to the server. Okay. Registration, you can just contact the admin. Okay. You can contact sir. I think ma'am is there or sir is there. Whoever is there in the session, you can contact them. Okay. Somebody has posted registration link. Sushmita ma'am, you are there in the session?
Yeah, yes, sir, I'm there.
Oh my god, so many messages, ma'am, about the registration link. My god, like too many messages. Can you just just talk to them?
Sure, sure, sir.
Yes, 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 yes. I think
Sure, I'll be sharing it right now.
yeah, yeah. Few people are having some issue, I guess. They are like bombarding me with a lot of
Yeah,
messages.
because
Yes, yes, yes.
yeah, there was some network issue from my side. That's the reason.
Yeah, yeah. And even then, I'm telling that please ask doubts for only on something related to the subject. They are just putting that. I can understand them, but yeah, ma'am has shared, guys. Please please do register. Okay. So please do the registration part. Shushmita ma'am has shared just now. Please do it. Yeah. Uh,
Thank you, sir.
okay, ma'am. Done. Done. Fine, ma'am. I'll leave the session. Let them register. Okay.
Yeah, yeah, sure, sure. We'll meet again by tomorrow at 7 p.m.
Sure, sure, sure. Yeah.
Yeah, thank you, sir. Yes, students, I request please don't ask this kind of questions to a trainer. As you all know, he is teaching you about the particular program or particular concept. If you are asking other questions related to attendance, registration link, everything, even he will get disturbance. I hope you all understood. So from tomorrow I request not to ask such kinds of questions. So in the last 5 minutes, you can ask the questions to me only. Like for attendance link, I know attendance is very important. I already shared it in a group, but still you people are asking. I mean, I have shared it in a chat. Please check it once, then you ask. Okay, fine, no issues. Like from tomorrow, as I told, please don't ask such questions to the trainers. He may also get some confused, right? I mean, he got a disturbance. He will get a disturbance. Okay, okay, guys. We'll meet again by tomorrow at 7 p.m. Okay, thank you all for joining. Thank you. Good night.